All right, so we're going to pick up where we left off last time. We were almost done with 2.1, and we were taking a look at this symbol, and the symbol that we were looking at one slide back was this element symbol. And we very intuitively said if we put a slash through it, it means it's not an element, and that's kind of where we left off, right? So what we're going to take a look at, hang on, slides are not changing for me, is an example. So we have example number 8, and it has the number 7, it has a blank spot, and then it has a set on the right-hand side, which is 3, -2, 5, 7, and 8. And the question is, which symbol is appropriate to put on the blank? Which symbol should I put here? Yeah, the E, the one without the slash through it, right?
What?
Oops. All right, so we're going to put this one right here. Okay, we're going to give it another shot, see if we can get it to cooperate with this. All right, so we're going to put the element symbol right here, it's an element because, why? Why do I get to put that one? Yeah, it's listed on the other side, right? So the element over here, and we've got it in the list on the other side inside of the curly braces. Now, here's the deal. Number 9's different. What is different about how number 9 is written? Yeah, it's in brackets. So that must mean something different. I mean, I didn't just do that sort of because, right? Right. I mean, so you're going to encounter some like this in your homework, and I want you to understand that it means something different. When it's put inside of braces like this on number 9, what that means is it is a set now. It's not an element. It's its own set, because that's what we do, right? When we have a set, we put it inside of curly braces. So there is a symbol that goes between this that will relate the two different sets together, but we haven't gotten there yet, all right? So since it's a set on one side and a set on the other side, what symbol? The one with the slash through it. It's not an element of it. It's actually what we would call a subset of it. So the correct symbol, given the two choices on this particular problem, okay, so given our two choices, the only one that will work in this blank right here is the element symbol with the slash through. It's not an element. Okay, it's a description sort of thing, right? It's a definition sort of thing, right? There are certain things that we mean that an element is, and this one isn't, because it's not an element on the left-hand side. It's actually a set in and of itself, okay? So it's one of those descriptor things that doesn't follow the description that it needs to in order for it to have the other symbol. All right, 2 more slides on this one. Okay, we're going to try again. So see, when you listen to this video later, you're going to hear me talking right now, and it's not going to make any sense because the video that's posted online will look like nothing went wrong. Cool, huh? All right. Set equality. Oh, where's my screen? All right, set equality. So let's talk about what we mean for two sets to be equal. All right, so two sets A and B are equal if every element of set A is an element of set B, and every element of set B is an element of set A. Make sense? So you might think, all right, that sounds like exactly what I would have thought it meant. Hopefully it does. But what that means is that we could describe a set in 2 different ways, maybe, and identify whether or not the descriptions match. That's a possibility. Or we could change the order of the numbers around in a set, and it would be the same set. Like the order doesn't matter because the elements are still the same elements. All of those kinds of things actually feed into our idea of what it means for the sets to be equal. Okay?
Hold on a second.
I won't switch yet. There's a lot of people still writing. All right, we have an example of this. All right, so what we're going to do is we're actually going to write true or false for each statement. The first statement is not about set equality. The second statement is. So let's do the first one first. We're going to write true or false. Number 10 says 6 is an element of the set containing the numbers -2, 5, 8, and 9. Is that a true statement or a false statement? False. False. This one's false. All right, so I want one person, raise your hand for me, one person to give me an example of how we could change this statement if we were asked to make it true. Leah, what could we do?
Well, it's clear that we can change an element of to not an element of.
Right, so one thing we could do is we could change the symbol between them. The symbol that's between them right now is the element symbol. If we put a slash through it, the statement would then be true, correct? Just contrary to what it looks like on the screen. It says false. You guys wrote down false, right? Great. Okay, we're going to do two things at once. We'll give it a try. All right, so one thing we could do then is we could put a 6 inside on the other side, right? And that would also make it a true statement. All right, you guys have the notes written down. And so take a look at problem number 11. Problem number 11, I know it's not on here, but pretend. Problem number 11 has the set on the left-hand side, x such that x is a natural number less than 3. And then on the right-hand side, we have the set with the elements 1 and 2. Okay, so they're not written the same way for sure, but the question is, are those sets as they are described equal? Yes. So this statement is actually a true statement. So you can fill in true on the right-hand side. Or, well, beside it, under it. Okay, so this is a true statement, and it's just two different ways of writing the same thing, yeah? Okay.